So we are given a question of simply supported beam with a uniformly distributed load applied on it. So at first let's design the beam. For that we will open workbench and we will go to static structural, and in the geometry section we will open the design modeler. So it's now ready. So before designing the model we will be setting its units to millimeter, since I will be using all the dimension in millimeter only. So now we'll go to XY plane, and let's first design the rectangular cross section of the beam. For that we will go to sketching and select rectangle and draw the rectangle. Now we'll be setting its dimensions. For that we will go to general, and I will be setting the horizontal dimension as 50 mm and vertical dimension as 40 mm. Now we need to center align the horizontal cross section above the central axis. So for that we'll go to vertical and set the vertical dimension as 20 mm, and now we'll go to horizontal and set the horizontal dimension as 25 mm. So it's now perfectly center aligned above the central axis. So now we'll go to modeling and select the sketch. So now we'll go to create and extrude and hit apply. Now I will be setting the dimension of the extrude section as 1000 mm, and now I will click generate. So now the beam is successfully generated. So this is the beam. Now we can close the design modeler. Now we'll go to model so this is our model. So at first we will generate the mesh. So for that we will go to mesh and we will be setting its element size to 0.005 meter. Now we'll right click on mesh and click on generate mesh. So the meshing is done. So this is the meshing. Now we need to create the hinge support at one end and the roller support at the other end. So let's first create the hinge support. For that we'll go to static structural and we'll insert a remote displacement. Now we'll select the edge at which we want to add the hinge support. For that we'll go to edge and select the edge and hit apply. So here the X rotation will be free and all other rotation will be 0, and all the components will also be 0. So in the hinge support only the X rotation will be free and all other parameters will be 0. So the hinge support is successfully created. Now we'll create the roller support at the other end. For that we'll again go to static structural and we'll again insert a remote displacement. Now we'll select the edge of the roller support. So this is the edge and hit apply. So here in the roller support it is only allowed to move in the Z direction. So that Z direction or the Z component will be free and Y component and x component will be 0. Now for the rotation part, x rotation will be free and rotation y and z will be 0. So we have successfully added the roller support. Now we need to add the uniformly distributed load over the beam. So for that we will again go to static structural and we will insert force. Now we need to select the face where we want to add the force. For that we will select the face and hit apply. Now I will be setting the magnitude of the force as 5000 Newton, but you can see that the direction of the force is acting upwards. So to change that, we will simply go to direction and click to change, and we will hit the black arrow to reverse the direction and hit apply. So now the direction of the force is acting downward. So we successfully added the force as well. So now we will go to solution part and we will insert a directional deformation, and I will be setting its orientation as y-axis since deformation will only occur along the y-axis. Now we'll again go to solution, and this time I will add a equivalent stress. So before solving the solution, let's set the max refinement loops as 3. Now we'll right click on solution and click solve. So it's now solving. So it is successfully solved. So this is the directional deformation of the beam, and this is the equivalent stress of the beam. You can see that the stress is maximum at its center region, which is shown in red color. So now let's see the directional deformation at the top surface of the beam. So in order to find it, we need to create a path from this edge to this edge. So in order to do that, we'll go to model and we'll insert a construction geometry called path. So first we'll select the start edge. So we'll go to edge and select the start edge and hit apply. And now we'll select the end edge where it will end. So this is the end edge and hit apply. So the path is successfully generated from this edge to this edge. So now similarly we will find the directional deformation along this path. For that we will go to solution section and simply duplicate the directional deformation without results. Now in the scoping method we will be setting it as path since we are only interested to find the directional deformation this time only along the path. Now we'll right click on directional deformation and click on evaluate all results. So this is the directional deformation of the beam along the path that we have created on the top surface, and this is the plot, and these are the values which is showing the directional deformation of the beam along the path at different points. Similarly, we will also create the equivalent stress along this path. For that we will go to equivalent stress and duplicate without results. Now everything will be as it is, no need to change anything. Now we'll right click on it and click. Before doing that, I forgot to change the scoping method to path since we are only interested to find this time only along the path. So let's first set it. Okay, now we can evaluate the results of equivalent stress. So this is the equivalent stress of the beam along the path on the top surface, and this is the plot, and these are the values which shows the equivalent stress of the beam along the path on different points. So This is the equivalent stress along the path in the top surface. This is the directional deformation of the beam along the path on the top surface, and this is the equivalent stress of the beam over the entire portion, and this is the directional deformation of the beam over the entire portion. So this is all about the question. Thank you.